which the original configuration of that structure has the exact same components as a modern methane gas digester.
I'll just explain how I met you, how I heard of you. So I was crawling out the Red Pyramid, and then I bumped into, I believe it's Larry from the pyramid. He has like he gave me his card, and I was literally like, I just like
it's
ascended.
The Institute of Pyramid Research, right?
Yes, and he was like, oh, I've just gone out to the Lost Pyramid, and then he was like, oh, have you heard of this guy? He's got this amazing theory about the pyramids being chemical plants, and I was like, tell me everything right now. So he's the reason why I found your YouTube, and I've probably watched about 10 vids, and I'm desperately trying to remember like my basic school chemistry to like keep up with what you're saying. But I was like, I've got to meet this guy, because I really honestly think that you are onto something. It just sort of explains everything.
I really appreciate that,
because I've been running around these pyramids for like 3 years. And I've read Christopher Dunn's book, and I was like, okay, I can get more on board with Christopher Dunn's version than I can with the mainstream, that these things are not tombs. I don't believe they're tombs. I've crawled in and out of them, and I'm like, this just doesn't seem right. It doesn't feel right. But then my problem with Christopher Dunn's stuff was, I was like, how do I apply that to every other pyramid? I was like, how?
Exactly.
But I knew that it was something to do with water is so important to every single site. Like, all of the things they have in common is they have the water, they have like the causeway, the channeling, and then something to do with the type of, very specific type of geology of the rocks and the order that they put them in. And they all have a chamber, and they all have like a descending passage. But I couldn't like put it all together until I saw your thing, and I was like, oh, okay, it all makes perfect sense.
Right. And so I will say, Christopher Dunn was the pioneer in sort of the alternative theories about the function or the possible function of the Egyptian pyramids. But I 100% agree with the statement that if you are going to present a theory about the function of these structures, it has to be a comprehensive theory. And all of the theories just focus specifically on the Great Pyramid, and they completely ignore all of the other pyramids in Egypt as if they don't even exist, or that they're just burial. All these other pyramids are just burials, and this is the only one that had a function. And I came to investigating evidence of this electricity production that everyone talks about. Yeah. And as I began to explore the sites, I didn't see any evidence whatsoever that was leading me to the production of electricity. But there were a lot of things that were pointing me in the direction of the production of chemicals on an industrial scale. So to introduce myself, my name is Geoffrey, and I'm the author of a book called The Land of Chem, as in the land of chemistry. Yep. And it's the long title is The Land of Chem, an initiation into ancient chemistry through the degrees of the Egyptian pyramids. And it's a story that tells the function of these structures, but also kind of my story of exploring the pyramids and all this kind of stuff. So it's a very interesting book. But yeah, The Land of Chem, and I also have a YouTube channel that explains all of the things that we're going to be discussing in today's presentation. And I pulled all of the best material from these previous episodes and put it together in a comprehensive overview for you. This is by far the best presentation I've ever given in terms of the slide deck. So I'm very excited to get into it.
I'm ready.
I'm ready whenever you are.
I'm comfortable. All right, here we go. Oh, okay, we're in. We're going in. So the floor is yours, Jeff.
Okay. It is known a chemical that was the first synthetic pigment that was ever produced and documented in the historical record. And you've probably seen this painted all over the Egyptian statues, and even inside the Pyramid of Unis, the stars in the roof are painted with Egyptian blue.
Yes.
So this is a very complex molecule and chemical. And this is sort of a preface to everything that we're going to be talking about today, as evidence not only of the sophisticated chemistry and the complexity of the compounds that were being produced, but this is also evidence that this civilization was producing chemicals and chemical-based products on an industrial scale, because they find this paint not only all over Egypt, but all over the Mediterranean world. So they can't just make one small batch of this stuff. You have to be making hundreds of thousands of gallons of Egyptian blue. And they've tried to study the manufacturing process that created this. Every time I start digging into stuff, I'm absolutely fascinated about what I find about the dynastic and even pre-dynastic period in terms of their chemicals, their materials, their technology. So this is the very beginning of my research. And I don't know if you've ever been out to Abu Sir, but this is a site. Yeah, it's absolutely spectacular. So again, this is 2017, my first trip to Egypt. And I was out there again, kind of looking for evidence of electricity production. So Yusuf, again, we got special permission to go out to Abu Sir, and Yusuf takes us out there. Shout out to Yusuf Awian. And I will give several shout outs during this presentation to people that have helped me get to where I am today. And Yusuf has been a huge part of that. And he's the Kemet school of ancient mysticism. Everybody knows about Yusuf. He's way more famous than I am, but I still want to give him his kudos because he's such an amazing guy. So he takes us out to Abu Sir, and I see this collection bowl and the conduit that is leading into the collection bowl. And the conventional explanation of this thing is that it's for collection of rainwater or drainage water. And to me, that just doesn't make any sense, because if you're doing a drainage conduit, you don't go through all of the effort to carve this from red quartzite, which is a very exotic stone that they had to take from very far away. And you certainly don't make a collection bowl for drainage water. It's the same thing as if, the drainage pipe on the side of your house. You don't collect that water. You just drain it off, and they could easily drain it back or somewhere else off site. You do not collect it. So what exactly were they collecting in these bowls? And this was the first artifact that I found that put me on the path of discovery to investigating ancient chemistry, because as soon as I saw this, I was like, oh, this is for collection of chemicals. And I knew that one day I would find the inlet to this conduit. So this conduit runs underneath the black basalt floor of the temple, and it heads back directly toward the pyramid. And I knew that the inlet of this conduit shaft would be eventually found at the base of the pyramid. So fast forward, I get my trip. So I went in 2017. I came back in 2020, 2021, and 2022. And I found, we had to be going around the back of the way, come to the front. We start around to the side. And as soon as I saw this piece of red quartzite, I knew exactly what I was looking at. And this is the original inlet to that conduit system that leads to the collection bowl on the other side. So this, if you were to turn around from this picture, you're literally looking at a destroyed pyramid. And it is directly at the base of the pyramid, which is exactly where I would thought it would be. Because the chemical that was being produced inside of the structure was then being introduced into that conduit system and collected on the other end in that collection bowl. And there's a very specific reason why it goes underneath the black basalt floor of that temple. And we'll be talking about the geology and the functionality of the geology later on in this presentation, because all of this stuff have very unique properties. And we've tested the properties of limestone, black basalt, red granite, and calcite crystal on a very unique machine. And I've got a slide in here talking about that. But this is kind of a preface of everything that led me into developing this theory. So I knew that I was going to find this thing one day. And as soon as I saw, I was like, oh, I found it. Yusuf, come over. I was like, check this out. And we were both very, very excited to find it. And it was in the exact location where I thought it would be. This is the inside of the red pyramid.
The stinky one.
Before the wooden floor was installed. And over here on the right, now there's a huge staircase that covers up this wall, and it takes you up to the final chamber. But this is what it looked like originally.
Wow.
And so I didn't know that we were going to get a chance to go inside of the red pyramid. I knew that we were going to go inside the Great Pyramid and get to explore some other sites. But again, Yusuf had some surprises for us. And again, this was my first trip, 2017. I had just gone to Abu Sir, seen that collection bowl, and my mind was already racing on the production of chemicals and the collection of chemicals. So that was our first site visit. Our next site visit was inside the red pyramid. So I go inside this thing, and I start seeing all the staining on the walls and the flow dynamics. If you look here on the left, you can literally see a staining pattern moving from the upper vault and flowing down through this connecting shaft.
Yes.
And that is an indication of the fluid dynamics of the chemical process moving through the structure. And the conventional explanation of the staining inside of the red pyramid and the smell of ammonia, because when you get to that final chamber, it smells like ammonia, very, very,
It stinks of ammonia, and I dye my hair blonde, so I know what ammonia smells like.
And it does.
I went in there and was like, "Oh my god, ammonia! It smells." And then I was like, "Is that pee? That can't be pee." And then I was like, "Nobody's peeing in this pyramid." And I was like, "It can't be the bats, because there are more bats in the bent pyramid than there are in the red pyramid, and the bent pyramid doesn't smell at all in any way." So yeah, I was like, "What's going on here?"
Very glad that you noticed that, because that's the explanation, is that the sting out of the walls is somehow caused by bats, and that this smell of ammonia is caused by bats. Well, I can assure you it does not smell like urine in there. And urine would have a very distinct smell, and guano would certainly have. And bats, when they're flying, they make droppings and it falls onto the floor. The staining does not come out of the walls, which is exactly what we see in the red pyramid. It's oozing out of the walls. It's extruding from the stone. So as soon as I heard that explanation, I was like, oh, this is nonsense. I knew that it was chemical staining. And fast forward 5 years, I will now later on in this presentation present a chemical analysis of exactly what this material is doing on the walls inside of the chamber. So again, this is a very chemical for fertilizer.
Yeah.
The reason we have our industrial scale agriculture today is because we started to produce ammonia on an industrial scale for fertilizer. It was the beginning of the modern industrial revolution and the production of chemicals on a large scale. So I was like, ammonia, fertilizer. Egypt was a huge agricultural industrial civilization. Of course, they would want to produce more crops. So all of the things just started lining up. And it was leading me more in the direction of investigating this ancient chemistry, because I knew that this was a chemical. As soon as I went in there, I knew what it was. It took me some time to figure out exactly how it was operating, but I knew that this was a chemical manufacturing plant for the production of ammonia. And we'll get into exactly how that works here in just a second. But I just wanted to show this to your audience, that there is massive chemical staining inside of this. And no one can tell me, look at this picture here. There's no way you can tell me that's from bats. So now I started to investigate the modern production of ammonia. And this machine over here on the left is the original apparatus that was designed by Fritz Haber for the production of ammonia on an industrial scale. And I just want you to take a look at the configuration of this machine and compare it to the configuration of the red pyramid.
Yeah, 3 chambers.
You'll see a little inlet shaft going here, leading into the primary chamber. The primary chamber is connected into the secondary chamber. And he even went through the effort of putting this one on a higher stand to make it elevated above the other chambers. He could have put this however he wanted to. Yeah.
I was just saying that the one of the things about the bent.
Ask.
The red pyramid has 3 chambers, and obviously in mainstream archaeology, like, well, why are there 3? If it's a tomb for one person, why build 3 different tombs? And then they're like, oh, it's to, like, so that you can put off grave robbers or something. And I'm like, that's the most ridiculous. Do you know how long it would take to build a chamber designed with the golden ratio and cut from stone? And I was like, I don't believe that they would just make 3 random chambers. I don't believe it. So this makes more sense to my brain, that they are reaction chambers for a reason, rather than people just making random chambers to put people off grave robbers.
And everything in my theory about the operation of these structures is literally physics and chemistry 101. It is very, very simple. We'll get into kind of the lost ancient high technology narrative at the end of the video, but I do not like calling this high tech, because in my opinion, that is a modern word. And if it doesn't have a computer chip in it, it's not high tech. This is very, very simple physics and chemistry. And so it's based on a principle. So imagine if you take a gas and put it in a box this big. If you then compress that gas into a smaller box, what have you done? You increase the temperature and pressure of that gas.
Right.
So that is why the top of the chamber gets smaller and smaller. And my theory involves introducing methane gas into this earth and using water to compress the gas into the upper part of the chamber. It's like a plunger mechanism that pushes the gas into the upper part of the chamber. You're reducing the volume and increasing the temperature and pressure, which is a great way to facilitate chemical reactions. And that's exactly what we do today. is if a reaction doesn't go on its own, you increase pressure, you increase temperature, and you introduce catalysts. And we're going to get to catalysts a little bit later. In the chemical analysis of the residue, shows that they were coating the inside of these chambers with metal compounds that act as catalyst material to increase the efficacy of these chemical reactions. So the red pyramid was also painted on the outside. And now we have a chemical analysis of the coating compound that was on the outside of the red pyramid. And I'll get to that here in just a second. Mm-hmm. So the word ammonia literally comes from ancient Egypt. The original name for ammonia is something called sal ammoniac, which means the salt of Ammon. And anyone who's familiar with the dynastic Egyptian pantheon knows that Ammon is one of the Egyptian.
Oh yeah, he's the main god. One of the main gods.
So methane production is very, very simple, and it all starts with cattle manure, aerobic digester for the production of methane gas. You'll see an inlet shaft going in one end, the main digestion chamber, and then an outlet shaft going in the other end. So it's slurry with water, cattle manure that flows through the inlet shaft. It goes into the main digestion chamber, and then the anaerobic bacteria from the cattle manure start the anaerobic digestion process that moves through the outlet shaft. The configuration of the step pyramid of Saqqara.
Yes.
Which the original configuration of that structure has the exact same components as a modern methane gas digester. It was originally a flat platform, that yellow platform, that had an inlet shaft going in from the north, a rectangular central chamber, and then an outlet shaft going out to the south. And everything else inside of that structure came along at a later period where there were modifications to the structure, there were tunnels dug, and they built a pyramid on top of it. And if you look at the one on the right, the configuration of these two things is exactly the same. There's an inlet shaft, there's a rectangular digestion chamber, and then an outlet shaft. So I am proposing that the step pyramid of Saqqara was originally designed to produce and harvest methane gas using an agricultural slurry that was based in cattle manure. And then the gas was just collected out of the top of that yellow platform, which is exactly how it's done today.
Yeah, that makes so much sense.
So this leads into, and there may also have been, so you may have noticed in Dashur, for example, that there is a modern petroleum refinery right next to the red pyramid. There's an oil plant right next to the red pyramid, that big closed off military base looking area.
Oh, yeah.
So there is definitely, there's some interesting geology underneath all of these structures. And some of those tunnels underneath the step pyramid may have been carved to tap geological deposits of methane gas. Methane gas was well known about in the ancient world. The ancient Persians had a fire-worshipping religion that was based on methane seeps. And methane forms naturally within the ground, and you can tap into these methane deposits to harvest the gas out of the rock. And we do this today, and then we also use these digestion chambers to produce methane gas. So I have a theory that both of these things were probably in operation within the step pyramid. But this goes directly into the deification of cattle in the ancient world. So, of course, and if you want to skip to the next slide. So, of course, cows were important as an agricultural animal. And we certainly know that, the constellation Taurus and all of this stuff. So again, we're talking about symbols that have two layers of interpretation, which is how all esoteric symbols operate. There's a symbol that's intended for the public consumption, and then there is a deeper interpretation that has another significance, in this case, related to ancient chemistry. So let's say that they were producing this acrid methane gas from the cow. It would certainly make a lot more sense that this became a godlike animal because of the magical chemical that was produced from the cattle manure.
That makes perfect sense.
And then we also have, I think so as well. And then we also have the scarab beetle. The symbolism of the scarab within the dynastic Egyptian religion never really made a lot of sense to me. So it's essentially a desert cockroach that pushes around balls of dung. It's somehow supposed to represent the rising and setting sun and this solar cycle of death and rebirth. So it never made a lot of sense to me how pushing around a ball of manure is supposed to represent the golden sun, this glorious resurrection and process that happens in the solar cycle. It just never resonated with me. However, if you look at that symbol from the perspective of producing methane gas, what is the first step of producing methane gas? You got to collect the dung. And that is exactly what the scarab beetle does. Than just this superficial religious symbol. It actually means something related to an incredibly important ancient science that was literally the foundation of their entire society. So they were doing ammonia for fertilizer. They were doing methane for heating, cooking, and lighting. So the ancient Chinese were using methane lamps, which is why you do not see any fire staining inside of the pyramids, because they weren't using torches. They were using methane lamps that are contained within a methane lamp apparatus, and there is no carbon staining. It's just a methane gas lamp.
Yes.
And it provides lighting. Yes. You can walk through these chambers and have a little gas tube leading to your lighting compound, and there is no carbon, there is no burning, there is no soot. It is a very effective way to light indoors without actual combustion of anything. You're just burning the gas.
Because this is what the problem is at all the sites. There's no torch marks on hardly any of the indoor stuff. And you're like, how did you carve the in the Serapeum? How did you carve and polish and refine all of the boxes? But yet it would take so much torchlight, and then you've got like soot and the like I was like they are using something other than torches for sure.
And I'm glad you brought up they call it the Serapeum here, right? So we Americans say Serapeum. Serapeum. So within the Serapeum or Serapeum, so what is that supposed to be? It is the burial place sacred bulls in Saqqara at the step pyramid. So the light bulbs, as soon as I started investigating all of this, the light bulbs started going off in my head. And the more you pull on that string, the more the mystery started to unravel that this is what these structures were for.
Do you have a theory to the boxes containers inside the Serapeum?
So I have a theory about how all these boxes operate. And they all have a very similar function, which we'll be getting to that at the end, kind of towards the end of the presentation. If you go to the next slide, you'll see a modern biogas digester. And we're still using these things in rural areas today. Farms, they take the agricultural waste material and also human waste, introduce it into this biogas digester. Then it's used for heating, lighting, cooking, basically everything you would need in a rural agricultural civilization. And then the digested material is also used as a fertilizer. So this is a very practical civilization, right? The same way we do today. Everything in our modern society is based on chemistry, chemicals, and chemical-related products. And this is a very practical interpretation for the function of these structures that I think is directly related to the actual civilization that we know about in dynastic Egypt.
And would make so much more sense that there would be this mass effort to create these huge industrial units.
Correct.
Because it would benefit everybody alive. Whereas if you're making a huge pyramid just for one dead dude, it doesn't benefit nobody but the dead dude. And I'm thinking that people are going to be way more invested in creating something that's going to light their house, heat their house, give them food, feed their kids.
100%. So these were infrastructure projects that were built to help reestablish the civilization after the cataclysm at the end of the last ice age.
Okay.
So this kind of gets into the timeline of the pyramids. So we have this massive cataclysm, and we're going to talk about Ireland here in a little bit, which is one of my personal favorite parts of the book and parts of my theory, because there's some structures in Ireland that also have chemical functions. Newgrange. And we're going to be talking about that in just a little bit. So let's say there's the cataclysm at the end of the last ice age. And there was a civilization that had this knowledge of chemistry. And from a perspective of someone who doesn't understand chemistry, it can be perceived as magic. You know, you take one solution that's clear, another solution that's clear, pour them together and it turns red.
Yeah.
Or if you light some sparks on fire, you could get green fire or blue fire, right? This ancient magic. So from the perspective of onlookers, this civilization had magic. And they also knew about physics, how to lift stones with very, very simple equipment. Again, from somebody that doesn't know physics, this was the magic of the ancient world, was knowledge of physics and chemistry. So this civilization flees from North America that had been destroyed in this cataclysm, and they spread across the world, bringing this knowledge of physics and chemistry that made them appear like gods, because they had so much knowledge, so much chemistry and physics that was not understood by these other people. So they arrive into Ireland, Europe, and Africa and start to build these structures to reestablish the civilization. So of course, they're going to need fuel, methane. They're going to need ammonia for fertilizer. They're going to need all of these chemicals to rebuild the entire civilization. And like you said, it was for the benefit of all of the people. So of course, they would have put a lot of effort into building these things and making sure that they would last forever, which is one function of the big pyramids surrounding these things. And I can get into this briefly. A lot of people ask, so why build the big pyramid around it? So with the methane, for example, it was to prevent environmental contamination. Because if you're producing massive amounts of methane, you don't want that escaping out into the environment. So you build a big case around it to make sure that none of that methane escapes into the environment. You have to encase all of that pressure in a massive structure to ensure that all of the pressure stays inside and the whole thing doesn't blow to pieces.
Yeah.
And we'll see something very interesting about that here in just a sec. So there's multiple functions for the body of the pyramid, and it's also involved in the operation of the structures in terms of the geology. So this is the configuration of the step pyramid. And basically what happens, you'll see down there at the bottom of the inlet shaft, the northern shaft going down, there's a little pit at the bottom.
Oh, of the red pyramid.
That is where the water. Yes.
The red pyramid. Yeah.
So down at the bottom, that is where the water was introduced into the structure. So the water comes in through this little pit and it starts to fill up the chambers. And the northern shaft is a pump shaft. It's like a plunger on a syringe. So if you take a block or a pump mechanism and slide it down that shaft filled with water, what's going to happen to the water on the inside of the structure? It's going to push it up.
Okay, it's going to start pushing it through. So you think that they would have had like a big
it's a pump.
Big plunger going down that shaft. Okay.
Essentially, yes.
Yeah, toilet plunger down the shaft.
Absolutely. And it raises and lowers the water level inside of that structure to control the chemical reaction process. And if you go to the next slide, I have a friend, John, who has started to model the fluid dynamics of the red pyramid. And it works exactly the same way that I have proposed it would work. And this was his first model. It's a very rudimentary model. If you go to the next slide, he's now making a full model of the red pyramid to demonstrate the fluid dynamics out of acrylic.
Yes.
And it works exactly the way that I have proposed. And if you look there on the left, this diagram is showing the bottom of the northern pump shaft inside the red pyramid. And you see that arrow pointing at something?
Yeah, it's on like a flat surface.
Correct. Right. So they went through a lot. So that would have originally been a 90-degree angle. And they went through a lot of effort to flatten out that area and make it a 45-degree angle. So this is, unless you're looking at the very, very small details of these structures, it gets completely ignored.
Because today they've filled it, haven't they? So when you're crawling down there, there's now a nice piece of wood so that you don't drop down that initial hole. And
correct.
So
there's a big shaft that goes down there. Yep.
Yeah, you wouldn't even see this stuff.
It's filled in with sand.
Great.
Yeah. And so if you look at that, right, so they went through a lot of effort to engineer. So an engineer designed this, like a chemical engineer, designed the structure. And every small detail is very important in how it worked. So this is a stop block for the pump. And if you go to the next slide, as the pump moved down that shaft, if it was a 90-degree angle, it would just get smashed to pieces. Every time pump hit that 90-degree angle, it would get smashed to pieces. So they eliminated that and they made it a flat surface so that the pump would slide down the shaft and rust precisely up against that stop block.
Genius.
So it is a beautiful indication of the function of that pump shaft. And again, it's a little tiny detail that nobody ever looks at that piece, because why would you ever look at that piece if it was a burial for a pharaoh? There's no need to go through all of the extra effort to soften out and 45-degree angle that thing if they were just putting a body inside of there.
No, 100%.
But if you look at it from the perspective of engineering, every single small detail matters. And this is what I started looking at in evaluating the structure and figuring out exactly how it works. So again, that is literal proof that there was I don't like to say proof, evidence of the fact that there was a pump mechanism moving up and down that shaft, and it rested very nicely up against that flattened piece.
So do you imagine this pump mechanism probably being another piece of stone with rope that they would like pull in and out? Or what do you envision the pump mechanism stick looking like?
So I think, the material was most likely stone, because they were basically using everything out of stone.
Yeah.
But there would have had to been some lubricants. It could have even been made out of wood, where there was a wooden pump that was lubricated on the outside and sealed, moving down the shaft that was operated from the outside.
Yeah.
So there would have also been, scaffolding mechanisms and all of this stuff on the outside of the structures.
Yes.
And now John is also discovering in his modeling of this thing that it doesn't even need the pump. The gravity of the weight of the water in that column and the reactions on the inside of the structure would have made it operate automatically.
Okay, so maybe there wasn't even a pump stick.
It really doesn't even need it in terms of the internal dynamics of the structure. And this is why we're trying to model these things physically, because I just came up with this crazy hypothesis. I'm not a chemical engineer. I'm just a guy who had a crazy experience in Egypt, and these structures started speaking to me. And my mind was open enough to consider the possibility that they could have been producing chemicals. So I started writing this book. I started developing the theory. And I hope to one day be able to model this in like a multi-physics modeling software where we can put a 3-dimensional model of this into the software and say, go. And it will literally model the heat distribution, the fluid dynamics, the chemical reactions, all of these processes. And again, John, with his working model, it works by itself. You don't even need the pump block. But I do think that there was something dictating the pressure within the system. Again, that little stop block is a good indication that there was something pressing all of this down.
Yeah.
But also at the Lost Pyramid, I just put out a video on the Lost Pyramid, and I had an exceptional expedition to this site. And there are locking mechanisms going down the pump shaft, which is another indication that it was locking this pump into place so that once it moved down the shaft, it's like a ratchet lock.
Yeah.
So as the pump moved down the shaft, it locked it into place so it could never slide back up, which maintains the maximum pressure inside of the structure. So there was tons of internal pressure. Go ahead.
That reminds me, because in a lot of the pyramids, you see what they describe now as portcullises. And they're like, this massive stone, granite stone here was a portcullis. And what it was to do, it was to keep out the grave diggers. And everything's to do is to do with grave robbers in Egypt. And I was like, I really don't think that this massive piece of thing was for a grave digger. It makes so much sense that there are these like big granite portcullis blocks that they would be able to move up and down when they needed to function or not function. Again, I'm just like, 10 points to Gryffindor. You got it right.
Thank you. So I also have a theory about the portcullis system in the bent pyramid.
Okay.
That the satellite pyramid behind the bent pyramid is a hydraulic press mechanism that is connected into the main structure to operate those stone valves. And
Okay.
every pyramid that has a moving portcullis system also has a satellite pyramid that was enclosed within the same reservoir. So these pyramids had reservoirs around them.
Mm-hmm.
They had walls, and there was a reservoir system. And all of the ones that have these moving stone valves also have a satellite pyramid in that same reservoir. And it's a hydraulic press mechanism.
Mm-hmm.
And I have, I think now 78 videos on my channel that explain every single one of these mechanisms and exactly how it works in very great depth.
Mm-hmm.
And we're already probably going to go 3 hours into this thing. So there's just a limited amount that I can get into all this stuff, but I explain all of this
Yeah,
stuff.
you've got very, very thorough videos, so people should 100% go, and we're just whizzing through it at this point because we need to get the message out. Like, guys, stop what you're doing.
We're looking again at the inside of the red pyramid and this staining.
Mm-hmm.
And fast forward 5 years from my first trip in 2017, when I knew that this staining was not from the bats. And I start working with the ACIDA project. Shout out to the ISIDA project, this international research group who's been they found my research. We both work with Yusuf. So we kind of reached out and they started sharing all of this chemical analysis from the samples that they took from inside of these structures. So they took samples, about 40 different samples from inside of the red pyramid from all different areas inside the structure. And if you go to the next slide, we'll start looking at the chemical analysis of exactly what this material is.
Okay.
So the first one is from an X-ray fluorescence analysis that shows the majority of this stuff is calcium oxide from the calcium carbonate in the limestone. But you'll also see in there's some silicon dioxide. There is some aluminum oxide, and then there's some iron oxides, which are very, very useful in terms of catalyst materials. Today, in our modern Haber process, the catalyst that is used is an iron oxide, aluminum oxide catalyst. And that is exactly what we find inside the staining of the red pyramid.
So this is the metallic paint that you think that they had that was a catalyst paint that they would coat the inside chamber with, and it would help, get it cooked.
Correct.
Great.
So there's also some material coming out of the stone. So you'll see inside the red, and you've seen it looks like the walls.
Yeah, it is. It's 100%.
And what would cause this? My explanation is because of the fluctuation of temperature and pressure inside of the structure. So it's extremely high pressure and then extremely low pressure. Mm-hmm. And it's causing material to melt inside of the stone and squeeze out, leaving these stains on the inside of the chamber. They're called extrusions. And the only way this can happen is if that stone gets hot enough to liquefy the material, because otherwise it's stone, it's solid. So where's this liquid coming from unless that stone was getting very, very hot? And it's like a sponge. A sponge isn't going to squeeze out material unless you squeeze it and release it. Fluctuations of pressure.
Yeah.
So all of those stains inside of the chamber are, again, evidence for these chemical reactions because the temperature and pressure are fluctuating inside of the structure, causing this material to squeeze out. So in this chemical analysis, we're not only getting the layer that has been painted on the stone, but you're also getting material from inside of the stone itself. So if you go to the next slide, this is the full breakdown.
Whoa, that's a lot of math.
Of all of the chemical elements that have been discovered in this staining. Mm-hmm. And you'll see that it's mostly iron.
Yeah, the Fe.
There is a Fe, correct. Yeah, and that's the majority of this material, which would make a lot of sense because the catalyst material in the ammonia production process is an iron-based catalyst. But you'll see there's also a ton of trace and somewhat radioactive elements in these samples. There's basically every exotic metal that you could possibly imagine coming out of this stone.
Wow.
So again, the conventional explanation is this is bat staining.
Nope.
And look at it. This is literal. Again, this proves that it's not bats.
It is proved it, yeah.
Because there is absolutely zero organic compounds in this.
I'm going to nickname it pyramid juice because I think that's what.
There you go. Because again, some of this stuff is coming out of the stone, and you'll see that in just a second. It's a material called strontium. So strontium can also be incorporated in the calcium carbonate limestone lattice. And the majority of that staining is actually strontium and iron oxide. But again, you have to get that material very, very hot to get it to squeeze out of the stone, and you have to squeeze it. Again, the fluctuations of temperature and pressure. So if you go to the next slide.
Yes. This is the electron microscopy.
Yeah. So now we're looking with real modern high technology to evaluate using a scanning electron microscope. They looked at tiny pieces of these samples. And you'll see that this first sample is 50% copper.
Okay.
So that's metal number one. If you go to the next one, this next one is almost 90% zinc.
Oh yeah, it is zinc. Yeah. So you've got iron, zinc.
This next one is an image of a piece of iron. Again, about 60% iron.
Yep.
So this is 50% SB, which is antimony.
I've not heard of that.
Another very, very interesting metal. And I have another slide talking about what antimony is and what it does here in just a second. But it was very important in dynastic Egypt. And this particular one is 50% antimony. This does not happen by accident. And what we're looking at here is evidence of this metallic sealing layer that was applied on the outside of the or the inside of the chamber walls.
Yes.
And if you go to the next one, this is where it gets very, very interesting, and this presentation starts to heat up a lot. So do you know what TH is?
No, I've not been to school in many years.
Neither did I until I started looking at it. It's thorium.
Thorium. That sounds like something out of a Marvel movie. What is thorium?
No, it's more like from an inside of a nuclear reactor.
Oh my God.
So thorium is a very, very interesting metal that we are still using today in the nuclear reaction industry.
So is that how they were getting the heat? Was that how they were getting the heat from these metals reacting with the...
So that's part of the process.
Part of it, okay.
So initially, these chambers were preheated with methane gas.
Okay.
So you put the methane into the chamber.
Yep.
You set it on fire. It preheats the chamber. Then you start the water filling process. You introduce more methane into that primary chamber. And it's a very long reaction process, but I can give you the overview.
Yeah.
So in the first chamber, the methane reacts with steam inside of that first chamber to produce hydrogen and carbon monoxide.
Yep.
You then lower the water. The gases flow through the connecting shaft into the second chamber, and then you raise the water again. In that chamber, air is inside of that chamber. Those gases react to produce carbon dioxide, hydrogen, and nitrogen, because there's lots of nitrogen in the air. Air is mostly nitrogen. So the carbon monoxide and oxygen react to produce carbon dioxide, hydrogen, and nitrogen. The carbon dioxide dissolves into the water because that's what carbon dioxide is, how you get carbonated water. Under pressure, carbon dioxide dissolves into water. So the byproduct dissolves naturally into the water, leaving hydrogen and nitrogen, which are the two reactants that create ammonia gas.
Wow,
so
there it is.
That bubble of hydrogen and nitrogen are then pushed using that pump block. The pump block is pushed all the way down the shaft. It pushes the water up completely in the structure, and it forces the bubble of gas in the final chamber through the connecting shaft into the final reactor. Yeah. That is why the smell of ammonia is coming from that third chamber, because that is the final.
And only that one, like really, like it's strongest up in that final, when you really get to the top of that final one, right at the very top of the roof, and you go, oh my God, yes. Absolutely reeks.
Yeah. So that was your final synthesis chamber where the ammonia gas was being created. And this is where all of that metal is found, from samples inside of that chamber.
So a question here, how do you suppose they would have then got it out once it's finally got to the final third chamber and it's reacted and we've got a load of ammonia? How do they bucket that?
Question. Yeah. So there's water inside of there. Gas is highly soluble in water. Aqueous ammonia solution. Which is basically what you have under your kitchen counter. So it dissolves into the water. then you drain it out of that pit, and then you collect it.
And you drain it, and then you found the drainage bowls that collect the ammonia water.
So that's at a different site, but they would have had, there is absolutely an extraction shaft in that pit. And that's why that pit was excavated, because there was a chamber floor in there.
Yeah.
And they found the hole, the drainage hole, and they dug out all of that material to see where that thing goes. That's why there's that massive pit inside there, because they were looking for something inside of there.
Yeah.
They were looking for the burial, the treasure, but there's no treasure in there. All it was is an extraction shaft leading out to take the ammonia out of that chamber.
Yeah. Idiots.
So again, they're in there looking for treasure inside of a chemical reactor. There was never anything inside there. That's why nothing has ever been found.
Nothing.
And there's more.
And that's why there's no writing, because humans weren't supposed to be inside these things.
100%.
I get that feeling. And the minute you crawl into that 3 foot by 3 foot shaft and you're going, this isn't for humans. No human was. Yeah. You designed this whole pyramid and you're telling me you couldn't make this 6 foot wide? No.
Right.
Sorry, doesn't fly.
I also did a video on my channel a while back called The Fallacies of the Pharaonic Burial Hypothesis.
Yeah.
Explaining exactly that. So what are you doing? Are you tying the pharaoh's body to a rope and sliding it down the shaft? And then how are you supposed to get all the burial stuff? How are you getting it down in this? A 3x3 shaft.
I think people don't. This is why I bought an 6 foot inflatable person, because I wanted to inflate it and drag it down the shaft, just to show for science how ridiculous it would be. Because I mean, carrying a dead body, you're going to need at least 2-3 people. You cannot fit more than one person in a shaft or at a time, and you'd have to slide them down 90 meters. Then you'd have to somehow hoist them over the pit. Then you'd have to get to the second chamber and then hoist them up another 20 foot up the next. Yeah. It's so disrespectful for any dead body.
Correct. It's correct. A very unceremonial process, right? Sliding them down the shaft and all this stuff.
No.
And we'll get to the Great Pyramid here in just a second.
Okay.
And we'll look again at the configuration of how ridiculous it would be to get a body inside there, because there's no way to you'd have to drag it up the well shaft.
Yeah.
You have to tie it to a rope, because the entrance goes down to the subterranean chamber. It doesn't go to the king's chamber. It goes down to the bottom. And there's no way.
Swing it all. You'd have to swing it up. It'd be smacking the sides. Its head would fall off.
Exactly.
It would be a nightmare. And the idea that people are like, no, this is the tomb. I'm like, it ain't a tomb. It is a very old machine.
Correct. And now we're getting to exactly what these machines were doing. These are the 5 metals.
Wow.
So it was copper, zinc, iron, antimony, and thorium. And I have a video coming up on my channel about ancient mining, metals, and metallurgy that explains exactly where they were finding all of these metals in Egypt, how they were mining them, and what they were doing with them. So one of the most important things in my theory is that if I present something, I want to be able to document it with scientific, academic evidence that these materials can actually be found in Egypt. Yeah. So everything that I've presented, I've backed up with chemical analysis, scientific data, and real academic publications that show evidence of all of this stuff being possible. Mm-hmm. So if you go to the next one, we'll talk a little bit about antimony. Wow. So antimony, I love this picture. It's such a beautiful picture of stibnite, which is a mineral that is mostly antimony. And I was a little surprised when I saw that antimony, but then I was like, oh, wait a second, I know why. And if you go to the next slide, so stibnite was commonly used in ancient Egypt. So stibnite is antimony oxide, and the ancient Egyptians were using antimony oxide to make cosmetics, eyeshadow. The black eyeshadow from ancient Egypt is antimony oxide from stibnite, and it was one of the first cosmetics that was ever produced. So again, all of the light bulbs should be going off, and all the connections should be starting to come together, because they were using these minerals, extracting the metals, and making compounds from them, which is exactly what we do today. There was a massive mining industry in Egypt where they were harvesting these raw materials, using chemistry to create all of these products. And it was a substance called kohol, which is black eyeliner. And it's still around today. Mm-hmm. It's still called kohol. And it's a black cosmetic that's made from antimony sulfide or antimony oxides.
Wait, hold on. Sorry,
So
you froze for a moment. So just to say that you found this inside the Osiris shaft.
yeah, so the containers down inside of the Osiris shaft are also sealed with a metallic compound that is mostly lead, but also titanium, zinc, iron, and arsenic. And I'll show that chemical analysis here in just a minute. And
Okay.
no one ever talks about this. I'm one of the only channels. Well, I found this on another channel from a Russian research team, but I'm the only one talking about the chemical analysis that are found inside of these structures.
You know, just to interject here, you know, one of my second favorite pyramid site is the one that I've never been to because it's stuck in a military base now in Egypt. There's a modern military base, and it's got one of the most amazing granite tubs because it's a very different shape. It's like
circular one.
Yes, it's a circular one.
Oh,
and when they found that, when they went down in the 20s, they said that the lid was glued on, and they had to prise the lid off because it was like literally glued with a substance. And then inside it was the only reference I found that there was like a sticky, they said that you could see like a residue inside the box.
Residue. Oh yeah.
And so that was like the first written historical thing that I could find that was like there was something in the box.
The pyramid of Geoffrey, and it's on a military base. And
I did a video on it.
Military base intentionally around that pyramid so that people can't go out there.
Yeah.
And they've done that at a whole bunch of other sites as well, where they build these military bases just to kind of fence off the area so that people aren't going out there. Down there at the bottom, so antimony. And antimony is a flame retardant in the textile and plastics industry and the manufacture of glass and pyrotechnics. So antimony has very useful heat retention and heat prevention properties. And that's one of the reasons that it was included in this metallic sealing compound. So all of these different compounds have functions.
Yeah. And
they included them as a reason to kind of mitigate the heat damage to the limestone blocks themselves.
Yes.
So because there's intense amount of heat.
Yeah. Dual function, keep the heat in the container, but also stop the damage to the stones. Perfect.
Correct. Right. So again, there's academic reasons for all of this stuff being inside there. So now we're going to talk about the thorium, right? So the thorium really caught my attention, and I wanted to make sure that I could document this. And this is one of the biggest discoveries that I've ever made, is the evidence of thorium. It's actually proof of thorium existing in the ancient world. So if you go to the next slide, this the land of Chem. This is the first slide that I ever made for a presentation, like 5 years ago, when I had no idea what I was doing on YouTube. And I was explaining the play on words about the name of my book, The Land of CHEM, instead of the name KHEM. So the word KHEM is the blackness. And conventionally, it is defined as referring to the black alluvial soil around the Nile River. So the land of KHEM is the land of this rich soil from the flooding of the Nile River. Okay? That's one interpretation. But then I started digging into the mineral-rich sands in Egypt. And if you go to the next slide, there is something called the black placer sand deposits. And these are located all across the Mediterranean coast of Egypt, Alexandria, etc. And it is a black sand that is rich in heavy metal minerals. And if you go to the next slide, you can see exactly where these deposits are located.
Yep.
So again, I was looking for evidence of this thorium. Where the hell is this thorium coming from? How could they have possibly gotten access to this material? And how did it get on the inside of a pyramid? So again, I started going down the rabbit hole of evaluating this chem, this blackness, and I start finding evidence of these heavy metal mineral sand deposits all over Egypt. They're quite a tongue twister there.
Heavy metal mineral.
So if you go to the next, go to the next slide, and I'm going to see if I can read this off of this thing real quick. So this is an article called "The Egyptian Placer Sand Deposits: A Potential Source for Nuclear Raw Materials." What? And so these black sand deposits are located all over the coastline of Egypt, and so these contain strategic and economic heavy minerals that are required for the industrial exploitation, whether for the nuclear industry or for other metallurgical or engineering applications. And I am definitely not proposing that they were making nuclear reactions or nuclear power of any sort, because there is no evidence of that anywhere.
Yeah.
However, as we've been discussing, there is definitely evidence of ancient metallurgy and ancient engineering, and they were definitely utilizing these compounds functionally. So what is inside of these black sands? So the sand contains, the mentioned deposits contain huge reserves of the 6 heavy economic minerals, which include monazite, zircon, rutile, ilmenite, magnetite, and garnet. And we're going to be talking more about monazite and ilmenite here in just a second, because ilmenite was another very important mineral in ancient Egypt. So the first 3 economic minerals, namely monazite, zircon, and rutile, contain uranium, thorium, zirconium, hafnium, and titanium, as well as rare earth elements. I discovered that this mineral-rich black sand in Egypt contains the mineral from So again, in my research, I wanted to be able to document, stumble across this article. I had come full circle to the first slide that I have ever created, and I found another interpretation for that KHEM. So the land of Chem, KHEM, may not have been referring to this black soil, but it was referring to these black mineral sands, where they were getting all of these complex metals and minerals. And so again,
they'd be able to create the sand, and then they could make paint from it. They could do metal alloys and whatnot.
Everything extracted from these sands. So again, it's a superficial interpretation that's for the public. Okay, so it's just this fertile soil around the Nile River. Okay, that works too. But there's also a stage, the first stage in the alchemical process is a process, the black stage. So again, there's another indication and connection to chemistry. And then I find this stuff about the black mineral sands.
Yeah.
So titanium dioxide can be used for paints, as well as in the metallurgical or nuclear industry. Rutile concentrate and zirconium would be used for ceramics. So we have all sorts of ceramics and also other applications where this could be used. And then so zircon and rutile can also be used in the welding rod industry, as well as the rare earth oxide cakes can be used in ferrosilicon alloys. So all of this stuff is barking up the exact same tree as what I have been presenting about the ancient metallurgy on these structures. And there's also, I'm pretty sure I put it in here, the chemical analysis of the Giza Plateau iron oxide deposits. So these iron oxide deposits all over the Giza Plateau also contain all of these trace minerals and metals.
Yeah.
And I have some very, very fascinating stuff coming up on the channel that explains exactly what was happening on the Giza Plateau. All right, so now the bent pyramid.
Right. Oh, my favorite.
So I have 2 different theories about the operation of this structure.
Okay.
The first would be that it's using the ammonia solution to make ammonium bicarbonate or urea. So you have your aqueous solution of ammonia, but it's a liquid. It's not very easy to store, not very easy to transport. So what we do today is turn that liquid into a solid.
Right.
It's easier to store, easier to transport, easier to bring out to the farms and apply to crops. So if you go to the next slide, as I just explained in the function of the red pyramid, carbon dioxide was a byproduct of the reaction. And we do the exact same thing today. And I have a video that just came out on my channel called Nothing New Under the Sun. What has been done will be done again. You know, this idea that there is nothing new. Everything that has been done in the past is done again. And this is exactly what we do today, is we use these same ancient chemical manufacturing processes where we're taking that carbon dioxide byproduct, reacting it with the ammonia to create either ammonium bicarbonate or urea. which are ammonia-based fertilizers that are solid compounds. And that's exactly what I proposed was happening inside of the bent pyramid. So you know that platform inside of the primary chamber, inside of the bent pyramid, the upper chamber?
Yeah.
There's that platform. So that was not originally inside of that structure. Even according to conventional archaeology, if you go back a slide, it shows the diagram of the bent pyramid.
Yeah, here we go.
Yeah, so that platform on the inside,
Yeah.
and all of those wooden logs were not a part of the original construction.
Right.
Those wooden logs were involved in the building of the platform inside of that reactor. And you may have noticed that the entire inside of the bent pyramid is very eroded, especially in that upper chamber. The walls were originally perfectly tiered like the inside of the red pyramid.
Right, okay.
And the entire inside of that chamber has started to erode. So what is causing this erosion inside of a pharaonic burial?
No, exactly. And that's interesting because when they were dating the bent pyramid, they were dating a lot from the bits of wood and things.
Wood, of course. Yeah. And it comes from the dynastic period. So that's where they get the date. But even conventional archaeology admits that platform was not originally a part of the structure. It came around much later. So that is a dynastic addition to the structure. Like mentioned, hey, let's patch these things up.
Yeah. Let's repurpose them.
We're going to start. Correct.
Yeah. And the idea, like the actual audacity to then say, I built this and this is for my son and I built myself 3 because I'm amazing. Like, no.
It's pretty wild. So if you go to the next slide about the Ostwald process about nitric acid.
Oh, here we go. Yes.
So this is an alternative theory I have about the function of the bent pyramid because you can also use ammonia to make nitric acid.
Okay.
And so as I have shown with the inside of the red pyramid, it was coated with a sealing compound. The same would apply to all of the pyramids because you have to seal these chambers, especially if you're producing acids, to prevent corrosion of the inside of the chambers. And we'll get to more acids on the Giza Plateau because I believe that the Great Pyramid was designed to produce sulfuric acid and the Central Pyramid was designed to produce hydrochloric acid. And they were using these acids to extract metals from those iron oxide deposits.
Okay. And that's how you make all the metals and they could make all the swords and they could make all,
So I get into that much. I haven't really even talked about that being related to the bent pyramid, but I promised you I would put some exclusive stuff in here. There's 2 different ways the bent pyramid could have operated.
Okay.
It's a very simple process using the carbon dioxide byproduct, reacting it in that primary chamber with your ammonia solution. You basically bubble up the carbon dioxide gas through the ammonia solution, and it creates ammonium bicarbonate.
Yeah.
And the lower chambers are separation chambers to allow the solid to settle at the bottom and the reactant gases remain at the top so they can be recirculated back into the primary reaction chamber.
And it makes sense why these chambers are so high up. Like the final chambers are so high up for a reason and a scientific reason, because you're pushing gases and waters and liquids up to a certain point that you need it to be, rather than, we're just making it really hard for people to steal the body.
So inside of the bent pyramid, the reaction starts in the upper chamber, and then the water and the solution containing the product flow down.
Oh, okay.
So so it's kind of the opposite way that the red pyramid works, where you're using that pump shaft to push everything into the upper chamber. When in the bent pyramid, everything flows down through that crazy connecting shaft, which is also extremely eroded. I don't know if you noticed how smooth everything is inside there. But there's a reason for all of that erosion.
Is that the tunnel that you crawl through, or is that a modern?
Yes. Yeah.
Right.
Yeah,
yes.
The connecting tunnel.
Yeah. Okay.
So there was an aqueous solution of product that flowed through that, and so now we can jump on in to the Great Pyramid.
The big one. Well, yeah. Not.
Okay. So now, looking at the configuration of this thing, going back to the fallacies of the pharaonic burial, the only opening to this thing is from the outside.
Yeah.
And it goes down into that subterranean chamber. The only way to get from that subterranean chamber up to the king's chamber is through that well shaft.
Yeah.
So again, you're going to tie the body in its golden sarcophagus, right? You're going to tie it and raise it up through that, and it's bang, clanging and clacking all the way up there, getting completely destroyed.
Yeah.
That is absolutely bogus.
No.
So again, just looking at this thing, there's no way you're getting a body down in there. And then how are you getting it up into the king's chamber?
Because you would, logistically, if I was going to plan a pharaoh's funeral, I would make everything processional, and I would make it exactly like the Valley of the Kings, where you can easily
huge openings
where you can have like 8 people side by side carrying coffins.
Absolutely.
And then you can very slowly, you make the descent really, really gentle. But pyramid tunnels are not gentle descents. They are like, whew, they're tough.
And there's a clear difference between the structures that were actually burials in the Valley of the Kings, because they had a procession, there's a whole big, celebration. They have all these people and they're carrying all this stuff in there, and you just walk it in there because it's a huge opening. It's a very slow, and it goes into this big old chamber where everything is decorated for burial.
It's ceremonial.
Huge difference. And it's very easy to see. So now let's look at the configuration of the Great Pyramid real quick. So we have 2 air shafts going into the king's chamber.
Yep.
Then you have your antechamber, which has very unusual acoustic properties. If you've ever been inside the antechamber, it's one of the loudest areas is inside that antechamber. Then you have your grand gallery that is sloping down toward your queen's chamber. So to explain the function of the lower pump system. So let's say you start with the opening on the outside and you pour water down in there.
Yep, so you're pouring it down.
Into the subterranean chamber.
Yep, with you.
Then you take your pump mechanism and push it down the shaft.
Yep.
It is going to push water up into the internal chambers.
It's going to push it up the well shaft, up into the grand gallery.
Again, a plunger, pushing water, so you're filling the inside of the chambers with water.
Yep.
So now let's go to the next slide.
Next slide. Here we go.
Okay, so this is showing the modern contact process for the production of sulfuric acid. And if you look on the far left, there's an air intake. There's actually 2. One is introducing sulfur dioxide into the chamber, and the other one is bringing air into the chamber. So the first step in the process in the operation of the Great Pyramid is you fill this thing up with water. Fill the entire grand gallery with water. Then you introduce sulfur dioxide and air into the king's chamber, which is your furnace chamber.
And you can do that because the air shafts go to the outside.
It opens to the outside.
Yeah. So you can
and there's another shaft leading into the pyramid from the underside as well, into the king's chamber. There's another hole down there. So you're bringing air. Water is filling the grand gallery. You've got your sulfur dioxide and air inside of your furnace chamber. There was an initiation of a combustion process that also involved methane gas to get things going. Then you lower the water in the grand gallery, which is going to pull more air in through the air shafts and pull those gases through the antechamber, which is what you can see there happening in that catalytic converter. They're pulling those gases, the sulfur dioxide and air, through a catalytic reactor into the grand gallery, where those gases then dissolve into water to produce a very dilute solution of sulfuric acid. And if you go to the next slide, it's a little bit easier of a diagram to understand. So your chamber is your furnace chamber.
Yep.
The air and sulfur dioxides are going into the furnace chamber. Those react to produce sulfur dioxide. The sulfur dioxide is pulled through the antechamber, which is essentially an acoustic catalyst chamber. It creates more reaction between the sulfur dioxide and air to produce sulfur trioxide, which then moves into the grand gallery, which is filled with water. The sulfur trioxide dissolves into the water to produce a dilute solution of sulfuric acid. Very dilute.
And so they would then collect the water coming out, and that would be your dilute, watered down sulfuric acid.
Correct. And I'll show you an example of how. So the inside of the grand gallery, the first time that I went in there, I was like, something was happening inside of this thing at an extremely high temperature.
Yeah. Yes.
The inside of the grand gallery looks like it's been baked in an oven, or possibly was an oven. And
it looks like it's been burnt. Yeah, I agree.
Correct. There's all of this white acidic staining in the top of the Grand Gallery, this oxidation in the top of the Grand Gallery, and the reaction between sulfur trioxide being dissolved in water is an extremely exothermic process. It generates a ton of heat, which is exactly why the Grand Gallery looks the way it does, because of the intense heat of the reaction that was occurring inside of that chamber.
Mm-hmm. And I agree, because let's just say, for argument's sake, if it was a tomb and it was all made at the same time, then why are you not seeing that level of stuff in every single corridor and nook and cranny of the, like, it's not uniform, it's just to that one specific room. Something happened in that room that did not happen in the other chambers. It didn't happen in the, so yeah, I don't think it's erosion of time or whatever.
So the next part of my theory is that the Queen's chamber is your extraction shaft chamber. And I propose that there's a shaft leading out of the Queen's chamber where this, so you go to the next slide.
Yeah, here we go. We're here.
Enter a new research paper, and you may have heard about this. So they've been doing all these scans of the Great Pyramid, the Great Pyramid Scan Project, the one that just, so there was another one that was done clandestinely from a satellite. And it's the title of this paper is called Synthetic Aperture Radar Doppler Tomography Reveals Details of Undiscovered High-Resolution Internal Structure of the Great Pyramid. So they scanned this thing from a satellite using Doppler radar technology. And they found all sorts of stuff that has not even been mentioned by the Scan Pyramid Project. And if you go to the next slide, we're looking at their analysis of the Queen's chamber. And you can see there on the bottom left and right, that's the Queen's chamber. And there's a shaft coming out of the bottom of the Queen's chamber. You can see it on the left from the scan, and you can see it on the right where they draw that little red shaft that's out of the bottom of the Queen's chamber. So again, this is literal evidence of exactly what I have proposed in my theory, getting backed up by modern scans of the Great Pyramid. That is the extraction shaft, where the solution was removed out of that structure. And if you go to the next slide,
go on.
Go ahead. They found a whole lot more stuff inside of that thing.
Because also, I was going to say, what about the void? That massive, like, jumbo jet-sized void. So
you'll see that in this diagram too. That big green box right there. So this is what they're proposing is found from using these radar scans. They've pieced together all of these things. And if you look coming out of the Queen's chamber there in the middle, it leads to a red chamber. It goes out to another chamber. So again, they're collecting it in a series of chambers and moving it out of the structure.
Okay. So it goes down from the Queen's and then, down into the little red. And then it would be left?
Into that blue one. Out to the... And that's underground or, within the body of the pyramid still somewhere, or these collection chambers. And if you look above, they have that big green box. Which is that void that everyone's been talking about.
There's a massive void. I mean, because it's freaking huge. I mean, the King's Chamber is big, so this is going to be massive.
So what can you do with the exothermic reaction inside of the Grand Gallery? You're going to want to use that heat energy, and you want to dissipate it from the chamber itself. So what do? You put a chamber above it, and you fill it with water.
A chimney, as such.
Well, it's more like a water boiler where you're using the heat from the reaction to heat up that water, and then you remove it from the structure. It's a cooling mechanism to remove the intense amount of heat from inside of the structure. You dissipate that into a water-filled chamber, and then that water can be removed, and you can use that hot water for a whole bunch of stuff. Steam is a very effective way to make things move. Again, steam engines.
So, there is so we've got the shafts, the air shafts that go into the King's chamber that go to the outside. And then the Queen's chamber has those two shafts that are really weird because they don't really go anywhere, but they do. There's like a stone block that has those copper handles.
Correct. Yes.
So how does that play into the sulfur dioxide theory?
So the big misconception is that those shafts inside of the Queen's chamber were originally opened on the inside.
Oh yeah, they were blasted open, weren't they?
They were not. They had to break through stone to get into those shafts.
Right.
So people, Dunn specifically has suggested that there was stuff flowing through those shafts into the Queen's chamber. But that is literally impossible based on the original config, because it was sealed.
Yeah.
So there's also remnants of the construction process inside of these structures. And if you go to the next slide, you'll see that they also found evidence of these huge steps kind of leading up. You see that kind of ratchet looking system?
Yes.
So this could have been from a system of water locks. So I've also proposed on my channel how water was utilized in building these structures. So those are water locks where stones were floated using buoyancy of wood. Lebanese cedar was prized in the ancient world because of the buoyancy. And they could absolutely float stones using either rafts or basically floats out of wood, floating these stones into the proper position. And those are evidence of water locks that raised these blocks up into the inside of the structure. There's a whole bunch of other theories about how this could have happened, and that's just one that I happen to think. So fluid dynamics was incredibly important to this ancient civilization. The flooding of the Nile River was the life of this civilization. So of course, they would have used water to facilitate these processes. And if you take a raft from the Nile River that has stone on it, you just float that raft all the way up to the building site. You can float the raft right into place. Then you unload the stone, put it right where it needs to be. A very easy process. Not easy, but it utilizes physics and knowledge of fluid dynamics to make what would be seemingly impossible very straightforward to accomplish.
I think I do agree that especially for the sort of 5-ton blocks, I think that is a very good theory that they could have water floated them, and especially with we know that there was a massive amount of trade with the Lebanese cedar wood, and it was so important to the ancient Egyptians. So that makes complete sense. Where I get a little bit stuck is when when you get it to the 500-ton statues, the 1,000-ton obelisks. I can't even imagine how that would work, like floating 1,000-ton. But
so instead of a raft, right? You get a bigger boat.
Right.
The bigger the stone, the bigger the boat. And they have depictions of these huge boats that were designed to float stones. I'm not saying that's the only way it could have happened. There's certainly some other theories that could be involved. There's a lot more about the Great Pyramid than we know. And there's still some things inside of that structure to be discovered. And the reason I put all that in there is, again, because it showed evidence of the extraction shaft that I had proposed is located inside the structure. So again, it's some modern technology that is showing evidence of what I've proposed, that this is a huge chemical manufacturing plant. So now let's move on to the Central Pyramid, which, again, everyone likes to focus just on the Great Pyramid. But if you're going to propose a theory for the function of the pyramids, it should address every one of them. So I started looking into the Central Pyramid. It has a very simple configuration compared to all of the rest of them. You just kind of go in, you go through a little passage to this main chamber. So what you're looking at here is a laboratory apparatus setup for the production of hydrochloric acid. What you do is you take sodium chloride, salt, you introduce sulfuric acid, that produces hydrogen chloride gas, which is a very dense gas. So it flows into water, and you can dissolve it to produce dilute solution of hydrochloric acid. And what did they find in the renovations of the Central Pyramid? That the inner chambers were coated with a layer of salt.
I remember it was 2 inches of thick salt, that's not happened in other pyramids, right?
Right. Again, evidence for exactly what I am proposing was happening inside of this thing. And I also found that during the renovation, before they opened that pyramid, they took machines in there and they processed the walls, and they removed the original coating compound that was covering the walls inside of that chamber.
Idiots.
Any sort of corrosion damage inside of the structure. So there's plenty of evidence that they've gone in and they've removed all the evidence. Laboratory apparatus. You have a reaction chamber with salt and sulfuric acid. You have a connecting shaft, and then you have a collection area where it's diluted into water.
Mm-hmm.
So now go to the next slide, and we'll look at the internal components of the central pyramid of Giza. And you'll find a very similar setup to the primary reaction chamber is where the sulfuric acid was introduced into that salt solution.
Yeah.
And I don't know, have you ever been inside of the central pyramid?
Oh, the second one,
Do
yeah.
you remember the big giant hole on the top near the upper portion of the chamber? There's a giant hole back there.
Oh, no. I was too
And
busy.
unless you knew what you were looking for, you may not have even. But there, oh, there's a giant hole, and nobody really looks at it because it's in the back upper part of the chamber. But I was like, there it is. That is the hole where the sulfuric acid was introduced. And I got a boost, and I stood on Yusuf's shoulder, and I looked up inside of that thing, and there's a shaft going back there.
Whoa, okay.
So this is your main reaction chamber. And then if you look at the configuration of this diagram, that hydrogen chloride gas is very dense. So it is going to flow down toward those lower chambers.
Mm-hmm.
And then if you, again, there's a reservoir around this thing filled with water. So you open your valves, you let water flow in through that top one. It is going to flow down into that low solution of hydrochloric acid. So what you see there on the right side of the diagram is a flushing mechanism where water was introduced into that portion of the structure. And you can see how it kind of drops down there. And there's water erosion inside of that area that shows that water was cascading down through that area. And then your lower chamber is your extraction chamber. So that gas just naturally flows down into that area. You open up the valve in the upper shaft. The water flows from the reservoir down through that connecting section, and it dissolves all of that gas, which is then extracted through the extraction shaft. So what you're looking at here is a casing block of the red pyramid.
Oh, yeah. You can see it's got its
And
little
you
coat
can
on.
see it's coated. And no one ever talks about the fact that these pyramids could have been coated or painted, but this is a coating or paint material that was discovered on the casing blocks of the red pyramid by the Osiris project. And they took samples of this material. And in the next slide, we start to talk about the chemical analysis of exactly what this material is.
Right.
And it is mostly composed of silicon and sulfur. There's some other things in there, but it's mostly silicon and sulfur trioxide. Sulfur trioxide may sound very familiar to what we were just talking about inside of the Great Pyramid. So this is literal chemical-based analysis that shows evidence that this civilization was not only producing sulfur trioxide, but using it to create other compounds. And in this coating compound, the sulfur trioxide is in its solid form because sulfur trioxide is usually a gas. So you have to take that gas, cool it to create crystalline sulfur trioxide to then create this coating compound. So the next slide is just going to show some scanning electron microscopy. And I love these type of images.
Yeah. Really
Because
colorful.
it gives small glances into the ancient past. So you can literally see the composition of these paints. And all of those different colors indicate compositions of different elements that are in these samples. So if you go to the next slide, this is again showing the chemical analysis of this coating compound. And you'll see there in the right column, it's mostly silicon oxide and sulfur trioxide. In, I believe, like so silicon about 14%, sulfur trioxide about 55%. The other one is about 28%, sulfur trioxide about 40%. And then the final one, it was silicon 33%, sulfur trioxide about 30%. So mostly silicon and sulfur. So I started doing some investigations into compounds made from silicon and sulfur trioxide. So go to the next slide and you will see exactly what this compound was. So this is yet another article from the Royal Society of Chemistry, where they are investigating a process for coating surfaces with a copolymer made from sulfur and a compound called dicyclopentadiene. Well, if you replace that dicyclopentadiene with silicon dioxide, this process will still work exactly the same, where these two molecules were fused into a paint or a coating compound. And I'll describe exactly what it says here. So the reaction between sulfur, and we're going to replace dicyclopentadiene with silicon dioxide. So the reaction between sulfur and silicon dioxide was optimized to form a shelf-stable and low molecular weight oligomer. After a simple curing process, the material was rendered insoluble and resistant to solvents and acids.
So it was an acid-resistant paint coating. Because they were making acids inside the pyramids, they had to make sure that it was going to be tight. So
this is in the red pyramid of Dashur, the structure that we're talking about, the production of ammonia.
Ammonia, okay. But still.
Right, but this is on the outside of the red pyramid. So this, I've also proposed that there may have been a cataclysm of some sort, an acidic rain happening in this area. And if you look at some of the erosion on the Giza Plateau, from the perspective of acid rain, it starts to make a lot of sense how some of this erosion could have happened, these crazy erosion patterns, right? They talk about the flooding of the Sphinx enclosure and all this stuff. Yeah. So what if it was acid rain that was eroding some of this limestone and creating this severe erosion?
Yeah.
So that's not the main, it's basically a sealing or coating compound, but it also has some very unusual properties. So taking advantage of the soluble oligomer, silica gel, which is essentially silicon dioxide, was coated with the soluble, and it was validated for mercury removal applications. So mercury is also used in gold processing. So this article is talking about some of the same things that I've been mentioning in this video: processing of gold, acidic resistant coating compounds. And down here at the bottom, this is where it gets very, very interesting. So the coating technique was also applied to metal, concrete, which is, replace limestone with concrete. So it was applied to metal, limestone blocks, and polyvinyl chloride to illustrate broad protection from corrosion and solvents. The coating was also repairable with surface scratches removed through the application of heat. So essentially, it is protected against acids and solvents and repairable when damaged. So this is a self-repairing coating compound. Paint. Yeah. Right? Everybody would say it's just a paint. But again, shout out to the Royal Society of Chemistry for digging into these ancient materials and discovering that there is so much more to the story than just a simple paint.
100%.
This was a very complex, acid and solvent resistant, self-repairing compound. And all of these structures would have been getting hot. So if there was damage to the outside, the heat from the inside of the reaction would seal everything back up, making sure that the compound and the coating compound stayed intact. Now,
into the Osiris. Oh,
and so I had special permission access into the Osiris shaft last year. Yeah. And it was just me and Yusuf.
Wow. That's cool. I also went down with Yusuf.
Oh, it was amazing. So as we start to go down inside, the electricity shuts off.
Oh my God.
So we had no lights going down inside this thing. So imagine going into complete pitch black darkness. I think we had headlights and all this other sort of stuff that we brought with us, but there were no additional lights inside of this thing.
Nope.
So all the pictures that you'll see, it was a wild experience. And you get down onto that second level and it is pitch black dark. And I sat in there, I turned my headlight off and I just sat down in there in the darkness. And I was like, holy shit, this is wild.
I've got claustrophobia. So when I go to Egypt, I have to fight my inner phobia. It was tough to go down the Osiris shaft, especially the drop. And I see that they've put a brand new ladder now. But I did not have a new ladder. I had the old rickety metal one that was like, it was terrible.
Yeah, so I was in there last year and I think it's probably still the same rickety because that whole thing was shaking And
No,
I
I've
was
seen
like,
I've seen a
going,
new one. I've seen a new one this year. There's like a
oh,
new
maybe as
silver, like a modern ladder. I was like, oh mate.
oh yeah, no, the one last year, it was like shaking all
Yeah,
over the place, and the thing was all rusted, and the bars were all bent, and I was like, holy shit,
we're
I'm
gonna
kind
die.
of a big dude. I'm like, and Yusuf and I are going down. I was like, oh my god,
Yeah.
like, it's quite an adventure going down in there.
Okay.
So on that second level, there's 2 containers down inside there.
Yes.
So before I went, I started researching the Osiris shaft. So one of those containers, the one in the far right, is made of a material called dacite.
Mm-hmm.
It's not red or black granite. It's dacite, which is not
in
found
Egypt.
anywhere else at any site in Egypt.
Mm-mm.
The other one, there was a chemical. If you go to the next slide, I'm showing the dacite container.
Oh, here we go.
And then the one down in the bottom under the water.
Yes.
So the second one on the other level, they took a chemical analysis of a coating compound that was discovered. And if you go to the next slide, this is another SEM image of this metallic coating compound. It wasn't on the dacite container. It's the one on the far left side. The dacite one is much older and it looks a little bit beat up. The other one is the one with sharper edges that has that oil staining on it.
Mm-hmm.
And the oil, that black material, is from that modern equipment that was down there. They had a wheel up there, and the wheel had dripped off and down onto the lid.
Mm-hmm.
But there's another layer of a metallic coating compound on that container. And if you go to the next slide, this shows the chemical analysis of exactly what that material is. It was mostly lead with a mixture of titanium, zinc, arsenic, and iron.
Wow.
So another metallic coating compound was discovered covering the exterior of these containers.
Mm-hmm.
And if you go to the next slide, we'll start to talk about what these things are and how they operate.
Got it.
Okay, so this machine is from Yusuf's shop.
Yep.
And it is a machine that generates an electromagnet. And I'm sure you've seen it and heard about this machine because other people have used it and done some experiments on this thing.
Yeah, I've seen Yusuf.
But I'm going to explain exactly how and why this thing works. Not the machine, but the stones.
Okay.
So the machine produces an electromagnetic energy field. We tested the limestone, black basalt, red granite, and white calcite crystal. So red granite and calcite crystal both have crystalline quartz within the material.
Mm-hmm. Up to 50%.
The limestone and the black basalt do not.
Right.
And you may remember that with the limestone, if you put a metal rod up to the limestone, it will allow an electric discharge into that metal wire.
Mm-hmm.
Same thing with the black basalt. It allows the electricity to discharge into the copper wire. So what is happening inside of this stone? So with limestone and black basalt, there is no crystalline material inside of the stone. But when you test the red granite and the calcite crystal, no discharge comes out of the stone.
Okay.
So the electromagnetic energy field has 2 different components. You have electricity and magnetism. So as the electromagnetic energy flows into the red granite, for example, the magnetic component of the electromagnetic energy field is trapped in the matrix of the stone.
Right.
The electricity flows into the quartz and is trapped inside of the quartz. That is why there's no electric discharge out of the red granite or the calcite crystal.
Because it holds it.
Correct. And everybody talks about piezoelectricity.
Mm-hmm.
It is not piezoelectricity, but it is something called the inverse piezoelectric property. So you're not compressing that quartz. Piezoelectricity requires compression of the quartz. This is something that is the exact opposite, called the inverse piezoelectric property that generates ultrasound. Everyone wants to know, what was the activation of the acoustic properties inside of these structures? It is from the inverse piezoelectric property that produces ultrasound. And we still use this same thing today, where electricity flows into quartz. The quartz produces micro vibrations that generate ultrasound.
Right.
So the limestone does not have any crystalline material. So the magnetic component of the electromagnetic energy field is still absorbed within the matrix of the stone, but the electric component is allowed to pass through, so which allows the discharge into the wire. Same thing with the black basalt, no crystal. The magnetism gets trapped in the body of the stone and the electricity discharges. So this, for example, is exactly what happens inside of the antechamber of the Great Pyramid.
Okay.
So the pyramid is built on top of ley lines, convergences of ley lines in this electromagnetic energy from the earth. That energy courses that electromagnetic energy field. Let me be scientific in my description and not say energy, because energy is a general description.
Yeah.
There's no such thing as energy, only electricity and magnetism. So the electromagnetic energy field flows through the limestone. It goes into the red granite, where that electricity is trapped within the quartz crystal.
Got it.
Causing ultrasonic vibrations, ultrasound. That is the activation of the acoustic properties inside of these structures, which there is something very miraculous that you can do with sound. It is called Sono chemistry, where sound can act like a catalyst in chemical reactions.
No way.
So I previously described how the antechamber of the Great Pyramid is a catalyst chamber. It is an acoustic catalyst chamber. So as the sulfur dioxide and oxygen are pulled through that acoustic catalyst chamber, the ultrasonic vibrations coming from the quartz crystal are amplified inside of that chamber, causing the vibrations of the molecules to increase. The more those molecules vibrate, the more they hit, the more they react.
Yeah.
So it's essentially like increasing the pressure inside of that system because you're generating more collisions between the molecules. It is sonochemistry and acoustic catalysts.
That again makes so much sense, because why would you make the tomb of a pharaoh like a whisper gallery? Do you know what I mean? Like there's no practical sense for why these pyramids are so acoustic, apart from if there was a function to the sound, because there's a dead guy. He's not even got ears to hear.
Correct.
So
the same thing applies in the Red Pyramid. These are also acoustically tuned vaults.
Right.
And I haven't gotten into the explanation of how that's involved in the Red Pyramid. I haven't even talked about this sonochemistry yet, but I promised you some exclusive stuff.
But as long as, that's new information to me. This is great.
I've sort of teased and again, people always want piezoelectricity, because they're so focused on the production of electricity.
Yeah.
But it has nothing to do with the production of electricity. It's literally the opposite, called the inverse piezoelectric property. An ultrasound machine works the exact same way, where they send ultrasonic vibrations into a woman's womb so you can get images of the baby inside of there. That's using sound technology, using quartz crystal.
Yeah.
That is the exact same thing that was happening inside of these structures.
Makes so much sense. Yep.
So now let's go on to the next one. So we can I knew this would be about 3 hours, and we're right about there. So the next one. So in the first experiment, and this is episode 33, I think, on my channel, we tested amorphous shapes of these stones. My next visit, I had Yusuf carve pyramid shapes because I wanted to test the shape of the pyramid as related to this electromagnetic field interaction. And I was hoping, again, kind of they imply that the pyramids are transmitting electric energy and this energy, blah, blah, blah. And it was coming out of the top of the pyramid. So I wanted to test that. So I had Yusuf carve shapes of pyramids from limestone and granite and all these materials. So we took the copper wire, started at the base. And as you get to the top of the pyramid, the discharge disappears completely.
Okay, so it's the actual opposite.
Absolutely nothing. And I have this on video showing the whole experiment. It's the electromagnetic energy field part 2 on my channel. Nothing comes out of the top of the pyramid. That is because of the reduction of surface area
Yeah.
If there is no surface area, there's nothing to discharge out of the top.
So the biggest discharge is
because
coming from the bottom.
Correct. So the pyramid shape is literally designed to contain the energy within the structure and not release it into the environment.
And that's
the exact opposite.
And that's
it's the exact opposite of what everyone is saying that these things are doing is, shooting laser beams out of the top or transmitting this energy from the top of the pyramid.
Yeah,
and I wanted to test. I was hoping, again, you hold that copper and I was like, oh, let's see it. And it was the exact opposite.
But that's why when you've got the foundations of the pyramids, they did the huge granite. There's like a granite base around the base, which makes complete sense because you want to make it non-conductive and to keep the actual pyramid, the limestone, the bit that's buzzing with ultrasound and right because around the Great Pyramid, they've got
central pyramid.
The central pyramid, there's granite blocks like make the base.
Correct.
Okay.
Correct. So that is designed to facilitate the transmission process, and so there's some stuff going on with that red granite base that I haven't really, but it's also to facilitate the transmission process.
Okay.
It's trapping that electric energy within the quartz inside of that red granite base, and it's keeping it there.
Mm-hmm.
Again, preventing it from further discharging into the environment, pushing that energy into the core of the structure. And we also discovered iron oxide deposits inside the core of the central pyramid. So these pyramids are all built on mounds of bedrock.
Mm-hmm.
And Yusuf pointed out there's a big hole into the central pyramid. And we looked up in there and there's iron oxide deposits inside of the core of the central pyramid, which I'll be getting to that later on my channel. I haven't really talked about that yet either. But there's reasons that these things are built exactly where they are. And they utilize mounds of bedrock inside of the structure that is filled with this iron oxide metal.
100.
Again,
The amount of difficulty it would have been to build it on top building on top and integrating into the bedrock is so much harder than just starting from a flat surface. If they'd done it 100 yards left or right, they could have done it on a flat surface. They chose specifically that specific spot, and it wasn't for aesthetics. It was for a reason, and that you're giving the reason.
Right. and they knew exactly what they were doing. And they used these natural mounds that were filled with this metal deposit, and they plopped them right on top of there for a very specific reason. So now let's go on to the next slide.
Okay, here we go.
So this is a picture of the black basalt outside of the Great Pyramid. There's that big black basalt floor out there.
Yeah, massive dark floor.
Yep. And what we're looking at here is a saw cut in the black basalt. And down inside of that saw cut, there is green copper oxide. So this is where we're going to talk about some of the metals that were used in ancient Egypt. And the whole myth is that it was pure copper.
Yeah.
But it was not just pure copper. And recent chemical analysis has shown exactly what this material is. So previously we were talking about those black mineral sands. And I said I was going to come back to a mineral called ilmenite crystal.
Mm-hmm.
And ilmenite is a naturally occurring mineral in these black sand deposits that is basically made of titanium and iron.
Okay.
So in these saw cuts, a number of different research groups have taken samples of this material, and they found two different things. If you go to the next slide, this is from a team that took analysis of some saw cuts from a fragment in Dashur. And what you're seeing there are tiny copper microparticles that remain from the saw blade. But it was not pure copper. It was something called arsenical copper. And I've mentioned arsenic already a couple times in this episode or this recording, that it was an alloy of 90% copper and 10% arsenic that completely changed the original properties of the copper, making it from a malleable metal into a metal that was as hard as steel.
Amazing.
This is the magic of alloy technology and sophisticated metallurgy. And again, I have an episode coming out. We're recording this on Monday. It comes out on this Thursday, where I talk about all of the alloys that were being produced in dynastic Egypt in an article that was published by Cambridge University Press.
Wow.
So it is a scholastic academic book that talks about all of the minerals, metals, and technologies of the dynastic Egyptians. And recent chemical analysis has taken samples from the core drills and the saw cuts, and they do SEM technology and X-ray fluorescence, and they keep finding the exact same thing. So they find two components. Go ahead.
I was just saying, so obviously the only reason why they say that copper is the only thing, because it's the only thing left in the archaeological record. So do you hypothesize that because these metals were really useful, that they would have been like melted down, reused? Like, why can we not find any saws or swords or anything with these metal alloys?
So they definitely have, and they have evidence in the archaeological record of, it's called arsenical bronze. And arsenical bronze is well known of in the ancient world as being the metal that was used to cut all these stones. And they do have remnants of this stuff, but absolutely anything made out of metal would have been either harvested from the sites, and we'll see here in just a moment where there were metal clamps at the lost pyramid site. And all of these metal clamps have been popped out and taken because metal was incredibly useful. Anything that was metal would have been melted down and repurposed, used by future civilizations. That's why there's not a lot of this stuff remaining. But there have been tons of chemical analysis that shows that it was an arsenical copper blade. And if you go to the next slide, they also have found in these saw cuts microparticles of ilmenite crystal. Ilmenite crystal being made of titanium and iron microparticles.
Wow, so it's really hard.
So it's a two-part process. You have a copper alloy blade made of arsenical copper as hard as steel.
Yeah.
So the mythology of copper not being able to cut, well, it's not pure copper. It's an alloy.
Yeah.
That makes it incredibly hard and durable. So the blade is covered. But it's not just the blade. They were also using abrasive slurries that had microparticles of these minerals in the slurry.
That'll do it.
And that is what really does the cutting. And it's the same thing in our modern Masonic process for cutting stone. They use a blade and then there's a slurry.
Yeah.
And the slurry has these titanium and iron microparticles that grind down into the stone and cut through the stone. And if you look at the next slide, this is a chemical analysis from a tube drill.
Yeah.
Where they found, see the greenish color?
Yes.
That is from the copper oxide blade. And they also did a chemical analysis of all of the material down in this tube drill. And if you go to the next slide, this is from the Met Museum. And I'm just gonna read this real quick because I think it's important for people to understand that ancient Egyptian craftsmen were exceptionally skilled and prolific in extracting and shaping a wide variety of stones. For millennia, soft and hard stones were quarried, cut, drilled, carved, and polished using a variety of tools and techniques. And it is generally agreed that abrasives played a significant role. Both saws and core drills used particulate abrasives, exactly what we're talking about with this ilmenite crystal and the titanium and iron microparticles. Used particulate abrasives, and the finishing of the sculptures was to be carried out with a combination of rubbing stones and abrasive slurries. Now, the rubbing stones, I could kind of discard that. But abrasive slurries and polishing compounds are still what we use today to finish stone because it has these tiny little microparticles of incredibly hard material that actually polishes down and finishes the stone. So this is kind of, again, some chemical analysis and some very academic data that is showing exactly how these stones were really cut. So scientific analysis using scanning electron microscopy and X-ray dispersive X-ray spectroscopy identified the material, this is talking about the slurry material, as a predominant mixture of angular grains of corundum, aluminum oxide, which is also found all over Egypt, aluminum being a very, very hard metal. And we've already kind of talked about aluminum being present in the chemical analysis of the red pyramid staining and in the coating compound that was applied to the inside of the red pyramid, with jagged edges of a few other minerals such as quartz, rutile, feldspar, apatite, ilmenite, which we've been talking about, et cetera, et cetera. It's talking then the very fine particles of calcite, et cetera, et cetera. It's basically saying that this is what was happening. They were using a blade and abrasive slurries to cut these stones.
Amazing. Well, yeah.
And if you go to the next slide.
Yeah, go on.
So I love these pictures of these scanning electron microscope images because it literally shows the traces of these ancient metals. And again, a glimpse into the ancient past of what was really happening with the stone cutting process. This was a civilization that had very sophisticated metallurgy, and they had a vast understanding of the minerals and stones that were present all across Egypt. They were master craftsmen, master geologists that understood the properties of these minerals, and they were harvesting these things and processing them down so that they could be used in all sorts of different applications, whether it be for making metal saw blades, the coating compounds, abrasive slurries. All of these different applications can be traced back to minerals and stones that are found all across Egypt. So it was a huge mining civilization.
This blows apart the kind of chronological timeline of like Neolithic, Stone Age, Bronze Age, Iron Age, because actually it shows that wasn't the case, because there was cycles of people using metal alloys way before they were supposed to be using them.
And they call it in the conventional archaeological record arsenical bronze, which according to their timeline did come around before normal Bronze Age.
Okay.
But again, they're kind of discounting the fact that the sophisticated metallurgy completely changes everything.
Yeah.
Putting just 10% arsenic changes it from a weak piece of junk that you can't cut anything with to a very, very hard metal saw blade.
Amazing.
And this is the magic of alloy technology. And we do it today where you mix a bunch of metals together and something that was a piece of junk turns into something that's basically indestructible.
Amazing.
But again, it wasn't just the saw blade, it was this abrasive slurry process. And in the next slide, you'll see I love these images. This is a fused particle because this cutting process absolutely generated heat. And they used to have these water troughs that flowed onto the stone to mitigate the heat generation process. But this is a fused particle where the saw blade material has fused with some of the abrasive slurry. And this is a particle of arsenic, tin, copper, and titanium. The arsenic, tin, and copper coming from the metal saw blade, and the titanium and iron coming from the abrasive slurry. So in the next slide, what type of machines were they using to cut these things? So this is a machine called the Hierapolis saw. And this is well documented as being used by the Romans. And it operates on a principle of something called gear ratios. And this is a water wheel powered saw blade. And you can see that water wheel is connected to a system of gears where one turn of your water wheel can be increased by your gear ratio into 100 or 500 or 1,000 turns of a saw blade. This is when you get the high speed cutting process.
Yeah,
you're not sitting there going like this,
Yeah,
they're not
because
like doing it like this.
You can see in the saw marks specifically where the saw marks have gone wrong, you can see that they're going at speed because they've gone wrong for a significant amount of time.
Overcuts.
If you were chiseling, you would work out pretty quickly that you're going the wrong way. Whereas these ones, they're gone, oh crap, I've gone 20 centimeters out over here. Let's, chuck this one away or whatever. The unfinished granite box in the Cairo Museum, exactly. So this,
perfect example.
Makes so much more sense that they would have
those overcuts.
Yeah.
So these saw blades were absolutely moving very, very fast.
Yeah.
But I certainly wouldn't call this machine a high-tech machine. This is very low-tech.
Well, I would call it advanced for for Stone Age, Neolithic, or whatever the time. So I think there was where there's a bit of lost in translation where what I can see what you mean. You see high tech as like electrical with something with a microchip, and I say if something was like high tech or advanced back then, I put it in like 4 times. So I would say this is like lost ancient technology because it was lost
ancient technology.
Yeah.
It was. Well, it's not really, because this is documented it being used by the Romans. And the Romans got everything they knew about cutting and moving stone from ancient Egypt.
Yeah.
Everything came from ancient Egypt. Everything that we know, chemistry, physics, etc., Egypt was the birthplace of all of these sciences.
Mm-hmm.
So the Romans took it from the Egyptians, but it was the exact same types of machines, where again, gear ratio physics 101, where one turn over here can create 1,000 cuts.
Yeah.
In a very, very simple process. And the next slide is just another example. And you'll see the water troughs flowing into the stone cuts. And there's a guy sitting there pouring something into the saw cut. That is the abrasive compound.
Yeah.
And I love it. This is absolutely an ancient machine. 100% an ancient machine. But it was made out of wood. It was powered by water. And it operates on very, very simple physics principles of gear ratios.
Yeah, exactly.
So it's more of a simple explanation than people might think.
Yeah.
And again, these things you could implement this even in a hand drill. So if you have one crank here, you have a bunch of gears in your little machine, and then you have your saw blade down at the bottom. This could be a hand operated machine where one crank here goes into a bunch of gears here, and you have your core drill down into the stone. So it doesn't have to be a huge machine that's powered by a water wheel. It could be something that was handheld, even made with wood, with a drill bit made of this arsenical copper, where you plop it into the stone. Zzz, and again, the one crank of your wheel here creates 500 turns of your saw blade. And you're using that abrasive slurry to introduce it down into the saw cut, right down into the stone. And it doesn't matter what type of stone it is. It's limestone, granite, all of these different types of stone can be cut with these type of machines. So the next slide is where things get even more, if it isn't interesting enough already. This is into my recent research.
Okay.
Since I have been living here in Egypt, I have already been out to this site twice. And this is a site called the Lost Pyramid of Dashur.
Yeah, I was going to say, I haven't seen this one.
At here. Yeah, so it's to the south of the Red and Bent Pyramids. And this video just came out on my YouTube channel on Sunday, my Sunday site visit 4, where I show my first expedition to this site. And I've already been out there twice since that first video has come out. So there's a whole lot more that's coming up about this specifically. And this site was recently excavated by the Ministry of Antiquities and Tourism. And what you're looking at here is the site pre-excavation.
Okay.
So a lot of this stuff is still intact. And you could just go to the night, get a couple of different views of the site on what it looked like before the excavation process. So you can see that these limestone blocks are still in place. Everything is still, this is how they find the site originally. And if you skip through the next couple, you'll go to one that has an A-frame.
Oh, wow, yeah.
So the first time I got down there, I was like, how the hell, even in the modern time, did they get equipment down here to lift this huge piece of granite up?
Yeah.
And you will see there is not a single piece of modern equipment. There is nothing whatsoever that is powered by electricity or gas.
Yeah.
What you see there is a metal A-frame and a system of compound pulleys. And compound pulleys are well documented in the ancient world, very simple physics-based machines where one guy pulls on the end of this thing, the pulley compound system works, and they lifted that stone. One guy can lift that entire granite piece of stone up out of the ground. And that is exactly what they did. And this was the same technology. Again, there is nothing new under the sun. What has been done will be done again. And this is exactly the same thing that the ancient Egyptians were doing to lift these stones, because you can't bring modern equipment out there. You can't bring a bulldozer out there. You can't bring a forklift or anything out there. So they had to use very simple technology to lift these stones and get into that reaction chamber. So they built this A-frame, they set up the pulleys, and again, one guy can lift this stone using a system of compound pulleys. And that's what they did. So I was like, how the hell did they get this thing out there? And then I started digging, and I found this expedition that was shown by the Smithsonian of when they went in there. So this was supposed to be the big reveal. This was a completely unexcavated and unopened site with a burial chamber that had never been opened.
Okay.
So they went out there. There's a huge expedition and all this, pomp and circumstance, and they filmed it with the Smithsonian. And they're out there with the cameras and stuff, and they have video of this. When they opened this thing, the look of disappointment on their faces is priceless. So they're cranking this thing up, and it shows the guys on the pulleys cranking this thing up, and it's just guys, simple, pulling on the pulleys, stone moving up very slowly. Because you have to pull it a bunch of times. That's the way compound pulleys work, is one pull doesn't do very much. You have to pull, and it just moves up very, very slowly. And they open this thing, and what do they find in there? A little wooden box that was empty and nothing else.
Okay.
They were expecting to find the first evidence of a pharaonic burial inside of this picture.
Not gonna happen.
There was nothing in there.
Yeah.
And again, the look of disappointment in the Smithsonian video, I'm going to be putting this out on my channel too, so people can see the reaction, because it's priceless. They spend all this money and they have all these people coming out to do this thing, and it's nothing inside of there.
Do they rationalize that by saying, oh, the grave diggers already got there?
That's what they said, of course. So, this is evidence of an ancient crime scene.
I'm like, no, sorry, but even when you have grave diggers, grave robbers, they smash and grab, and they take what's valuable, and they leave anything that they can't. So there is stuff that there's like forensic evidence everywhere of that. So you'd have shards of pottery and bits of this and beads and bits of sauce and whatever, because you'd smash and grab only what you need, and you wouldn't forensically take everything out of the tomb. So I don't see, and there's no evidence of anything inside these pyramids apart from.
So now this site has basically been completely abandoned.
Wow. Because
they didn't find anything there. They were like, all right, fuck it, we're going. There's nothing to see here. And it's not necessarily an off-limits site like Abu Seer and Abu Garab, but it's definitely not a tourist site. And you'll see in the video how difficult it is to get out there and exactly where this thing is located.
Okay.
But if you go to the next slide, these are some pictures that I took in my recent expedition out there. And there are these channels running down the side of the structure.
Yep.
There is a locking mechanism in the pump shaft, which would have held this pressurizing pump in place. So if you go to the next slide, this is a close-up of those channels.
Whoa, look at that. Why do you need running channels for a tomb? I'm sorry. There's no reason why you would need running water or anything for a burial site.
Correct. Again, indications of fluid dynamics, moving water, moving chemicals. And it does look like there was something mortared into those channels, which is most likely a copper or some sort of piping system.
Yeah.
And you can kind of see there the anchor points. If you go back one slide, there's an anchor point in the previous slide that you can see in the bottom left corner.
Yep.
So there were metal anchors in the stone, which have all been popped out and removed.
Yep.
And there are huge anchors holding these stones together. So they are not only mortared together, but they've been anchored with these metal anchors. So why go through all of this process of making sure that this thing stays together if this is just a pharaonic burial?
100%.
That is because of all of the massive internal forces that were involved in the operation of this structure and the immense amount of pressure that was generated inside. Pressure and vibrations, right? So this whole thing is shaking and pressurized and vibrating. So they put all these anchors in here to make sure that the whole thing doesn't fall apart when it was in operation.
Yeah, that's crazy.
So if you go to the next slide, now this chamber is opened. They've raised this granite lid.
Whoa.
And you can see the picture of the meeting. And I intentionally didn't put the picture of what's inside there because I want people to go watch it on my channel because it's an amazing video. And this is my first time out there. So you can see I'm like, freaking out, like, and all the stuff is like my literal on-site reaction to seeing all of this for the first time.
How is the granite block staying up there? How's it staying up?
Yeah, so they put railroad ties.
Okay.
They prop the thing up, and there's 3 railroad ties on each side, wooden railroad ties that are holding this massive thing up. You crawl down in there,
I'd be so
And I
scared
can
to
say
crawl.
the acoustic properties inside of this little cavity are absolutely mind-blowing.
Okay.
And if you hit the right note, which I finally got a chance to do, the whole thing starts shaking.
Wow.
So we've already talked about how the electromagnetic energy is coming up from the earth into this reaction chamber that's made of red quartzite on the bottom and pink granite on the top. So again, that electromagnetic energy is flowing into the stone. The magnetic component is being absorbed by the matrix of the stone. The electric component is flowing into the crystalline quartz material of the red quartzite and the pink granite, activating the inverse piezoelectric property that produces ultrasound.
Wow. Yeah.
So the whole thing was designed to produce acoustic vibrations and pressure.
Yeah. Oh, it's
Sono chemistry, acoustic catalysts that were driving the chemical reactions inside. And I haven't put together a full theory of exactly how this thing works because there's so many missing components and the entire structure has been dismantled. But in my recent expeditions, I'm trying to put together the pieces and I'm going to feature the development of my theory in real time on my channel so that people can see my thought process while I'm evaluating all of this stuff and trying to figure out all of the details. And it's been a super exciting adventure for me to be able to do this thus far. And so we can close on the last few slides and talk about Abu Garab.
Right.
And I put these at the very end. I know you wanted to talk about this. So I'll preface this with a couple of things. So Abu Garab, you go in there and there's two different types of bowls.
Yes.
They have the limestone bowls with 3 holes. And then there's the calcite bowls with the 1 hole. So the limestone bowls with the 3 holes, you can see the original housing for these things on each corner of the pyramid. And I've shown this in some site expeditions. So there were 4 bowls with 3 holes on each corner of the pyramid. So there were 16 bowls total. Those limestone bowls with the 3 holes going into them. But then you have this other set, if you skip to the next picture. So this first picture is showing the limestone bowls with the 3 holes. And the next picture goes to the calcite bowls. Completely different material, completely different configuration. And those limestone bowls, nobody knows where those came from. There's no evidence of the original housing for those bowls on the site. You can see pieces of the limestone bowls, and you can see the configuration of the housing on each corner. But those calcite bowls may have come from this site. Nobody knows exactly where they're from. The next one shows the hole, and then the following slide shows that green copper oxide that is in some of the crags of this bowl, which is an indication that was originally sheathed in copper. So just shameless plug. I wouldn't be any good if I didn't put a shameless plug in there for all my stuff. So of course, there's Land of Chem merch that's available on my website. So my YouTube channel is the Land of Chem, CHEM. My Instagram is the Land of Chem, Land of CHEM. And my website is www.thelandofchem.com. You can scroll through just the next couple of images. I have all sorts of merch. And at the very end, it should be a picture of my book, which is my life's greatest achievement. And it is a small book. It's a novella that just tells the story of exactly what we've been talking about in today's presentation. The Land of Chem, an initiation into ancient chemistry through the degrees of the Egyptian pyramids. If you want to support or just come follow the material, come visit me on Instagram, YouTube. Johanna, I cannot thank you enough for this opportunity. And you have been so kind and so patient and just dealing with the technical difficulties that we've had. And I know we've been on for almost 3.5, maybe 4 hours now. So hopefully in the editing process, this turns out to be actually something that's usable. And
no, it's been amazing.
It's
been amazing.
I cannot thank you enough for this opportunity. It means the absolute world to me. So from the bottom of my heart, thank you so much. And to anyone that comes over to my YouTube channel, I appreciate the support more than I can ever explain. So just thank you so much. Yeah. God Almighty Creator, thank you so much for letting us get through this presentation. I was not going to quit, and whatever it took, we were going to get through this. So thank you so much for the opportunity.
100%. No, that's fantastic to have you on. And I know that like everyone's going to be absolutely, this is what we've been looking for. Been sort of like throwing around ideas. And I always say to anybody, like, any idea isn't a stupid, like just throw it in. Like, because you've got to have different people looking at things from different points of view and then go, hey, what if that is upside down? And what if this is this way? And what if it isn't, you know? And so I'm so excited because this is one of the first ideas that I've gone, this explains everything. Completely feasibly, completely scientifically. I don't know how long they're going to be able to keep pushing the pyramids with tombs. Like they've got it literally in scientific evidence here that there was, you know, you're changing it. So this is really exciting, and people need to get over and catch you while at the beginning of your adventure, because it's only gonna get wilder.
It's pretty wild. And I feel like God in the universe brought me here to Egypt for a very specific purpose, was to come here and to do this full time. Because before I was, you know, working a 9-to-5 job and putting 90% of my energy into that and 10% into this. But now I get to do it full time. And it's been absolutely magical experience being able to be here in person. And I just can't thank you enough. This means so much to me. I'm like almost in tears at how grateful I am for this opportunity.
We got to get you out. You're going to be on Rogan 100% because he loves this. So we'll get you to Rogan.
One day, slowly but surely. Again, I'm trying to put in the legitimate work to make sure that everything I do, again, is very scientifically verifiable. And I want to be able to earn these things. You know, I don't like when things are just given, but sometimes God works in mysterious ways. And had you not run into Larry there at the Bent Pyramid, you know, like working in conjunction, it's like, you know, sometimes things happen that are completely out of our control. So I feel like that was in God's hands to bring us together. And thank you so much. This has been I know it's been a wild ride, and hopefully again, everything turns out well in the editing room and this comes out.
Have a great day.
Anna, thank you so much. And we'll cut now. Again, thank you so much.